We are now at 3 after. And we can go ahead and get started. Let me get everything pulled up here and we are good to go. So for all of our attendees, I would like to welcome everyone to the NAIRR Pilot Partner Series. Welcome back. We are once again here for another Pilot Partner webinar. Today, we are having a 30-minute presentation with about 10 to 15 minutes for Q&A afterwards. So if any of our attendees have any questions, please submit your questions via the Q&A button in Zoom. All of our questions will be handled at the end of the presentation. Today's presentation is for Groq, and we have Tim Klawa, who is here to give a presentation. I will go ahead and end my sharing, and Tim, you are welcome to begin whenever you would like.
I appreciate it. Yeah, so my name's Tim. Recently joined Groq back in August of this year as the public sector field CTO. I guess I'll turn it over to the other Tim to introduce himself.
Yeah, thanks very much. So I'm Tim Angelos. I'm a public sector sales leader with Groq based in the Washington, D.C. area. Tim Klawa is going to introduce himself a little bit more, lead you through a discussion demo on Groq, and then we'll wrap it up with some Q&A at the end. So thanks very much for joining. Ella from Groq might be joining as well. She's part of the team that helps support the NAIRR project. So thanks, TK. I'll turn it back over to you. Thanks.
All right, thanks. So I'll go ahead and share my screen. Just want to check that everyone can see it okay.
We got it.
All right, so like I said, my name's Tim, public sector field CTO here at Groq. And basically what we provide is fast AI inference. And so the other Tim and myself were both part of focusing on how we can accelerate AI adoption in the public sector. And so there are a lot of use cases that are sprouting up around taking these large language models and integrating them into a variety of enterprise or niche applications to really augment decision-making processes and accelerate value that can be provided by the public sector. And one of the things at Groq that we've set out to solve is really about optimizing AI infrastructure to be able to handle the massive amount of compute workloads necessary to run these AI models. So I'm sure you guys have heard in the news about the energy constraints on our grid, the data centers having to be built around the world to be able to keep up with the demand of running some of these large language models. And really, we can think of it as AI is rapidly accelerating with the adoption of generative AI, but legacy infrastructure is really holding it back. And so that was really the premise of what Groq really set out to solve. And so we were actually founded in 2016 by Jonathan Ross, the creator of Google's TPU, or Tensor Processor Unit. And so back in 2016, before ChatGPT hit the scene and all of that, really Jonathan Ross at Google saw that with the wide adoption of AI, there was going to come a shift from training models to running AI models. So back in the day, right, Google had massive AI inference workloads that inspired them to create the TPU. And Jonathan Ross basically wanted to develop AI infrastructure that would unlock that for other companies and enterprises around the globe. And so he created what we call the LPU, or language processing unit. And it's right there up on the screen as the Groq chip. And so each Groq chip goes into a Groq card, which goes into a Groq node or a server. And those servers are racked and stacked in a Groq rack. And that basically is the core component of developing the Groq compute clusters, which power our Groq cloud. And so we have data centers deployed around the world that power our Groq cloud, which we'll talk about in a minute. But just a little bit about our chip and what's different about us. So one thing, we are designed and manufactured in North America, and we're the only AI chip that provides deterministic compute that outperforms GPUs for AI inference, both on speed, cost, and energy efficiency. So you can really think of the LPU as a very efficient chip at linear algebra operations. So we can serve a wide variety of different use cases, everything from real-time kind of series analysis, natural language processing, computational sciences, anomaly detection, or computer vision. The primary focus of a lot of our workloads in the commercial sector, and if you go to like Groq.com and look at the models that we support on the commercial sector, heavily focus on large language models just based off of the demand that we see in the market today. And so a little bit going deeper into the differences between a GPU and an LPU. So GPUs from NVIDIA, they're amazing technology. They're really great at training foundational models. And so the difference there is that the LPU is purpose-built just for running those models, not necessarily for training them. So some of the differences, for instance, GPUs require HBM or high bandwidth memory. And so when you hear basically NVIDIA talking about that they're going to develop 5.5 million GPUs per year, the bottleneck to that production is really the fact that there are only 3 companies in the world that produce HBMs, and there's only 1 company in the world that does the CoWoS manufacturing process. And so there's a supply constraint that makes it challenging, expensive, rare materials, very complicated manufacturing processes that make the development of GPUs costly and lengthy. So if you were wanting to stand up a new GPU center, it might take 2 years after you order to actually get those GPUs, and very, very expensive to do so. One of the differences, though, with our chip is that we don't rely on HBM. We use SRAM. We have memory on chip, and we've designed the chip to be deterministic and to use an assembly line architecture. And so you can kind of think of the differences as, you know, if you were going to imagine data flowing through a compute cycle, kind of to, as an analogy I like to use, a city and traffic moving through that city. A GPU is kind of like navigating through a city where you have a lot of different roadways and a lot of different routes that you could take, but all the traffic lights are independently scheduled. And so you never know exactly when you're going to arrive at your destination, but you have a lot of different optionalities to get there. You could end up in a traffic queue, things of that nature. That type of architecture is great for training foundational models. The difference there for AI inference with the LPU, it's very similar to going down a highway or roadway where all of the traffic lights are aligned so that you always hit a green light. And so basically we do that with a software first approach to our compiler, where the scheduler basically pre-plans the execution sequence of each compute cycle when we do the compile. So we know down to the chip cycle exactly how long it's going to take to do that execution. And that's what we call deterministic compute. And it's something that Tim and I both see very critical for sensitive defense and intelligence type workloads, where knowing exactly how long it's going to take for each compute cycle is super important for AI augmented decision support systems, where you're relying on the input or analysis from an AI model before moving to the next step in a particular chain. And so as we kind of see, like I mentioned, the shift from training these foundational models to running these foundational models, training a large language model is not a trivial process. And so there's a lot of capital intensive resources that go into that. And so we're seeing a shift in the market where there's fewer and fewer people that are really focused on building the next competitor to OpenAI or Anthropic or Google's Gemini. The majority of people implementing AI are focused on running those AI models. And that's where we're seeing a shift in the market, where basically we're going from training these really large models to needing the type of compute infrastructure to run those models. And some interesting analysis actually by Minio Ventures predicts that basically the work is going to center around inference up to around 90% of compute for a lot of enterprise workloads that integrate with generative AI or other model architectures are going to be focused around running these models. And so really the hard part is where the real value begins. And so after you have this model, you want to plug this model into whatever system you're developing, whether it's automating some manual workload or workflow or developing some AI agent. As soon as you take that pilot and flip it over and start giving it to thousands and thousands of users, that compute there is part of that AI inference. And really what Groq provides is AI infrastructure that's tailored to provide that type of compute faster, cheaper, and more energy efficient. And so one of the things to note about our architecture is unlike a GPU data center that requires liquid cooling, we only require air cooling. So we're not dependent on water resources, and we use a fraction of the energy necessary to actually provide the same type of token per second on high volume workloads. And so recently, in the last couple of years, we launched the Groq Cloud. And this is how a lot of individuals interface with our hardware around the world. And you can think of this as a software stack that sits on top of our hardware and allows people to run their AI workloads on our LPU chips. And so after we launched Groq Cloud, in about 18 months, we already had 2.2 million developers signed up around the world to leverage the variety of different models that we have hosted as part of the Groq Cloud. And we're currently generating about 50 trillion tokens per month. And so just to put that in perspective, it's similar to basically generating every single book in the Library of Congress 16 times every single month. And so that's a massive amount of workload that we're able to provide at a cheaper, faster, and more energy efficient perspective to our clients. And so I wanted to take a second to showcase a couple different statistics about running models on Groq versus our competitors. And one of the websites that I highly recommend is Artificial Analysis. So if you go to Artificial Analysis, you can pick whatever type of metric that you're most interested in, pick the different providers that you're curious about, and then look at the analysis to see what makes sense for you for a particular model that you're interested in. And so in this case, we're showing a benchmark of Llama 3.3 70B spec decode performance. Basically, the output tokens per second, in this case, the higher the better. You see how Groq basically compares to all the other competitors on the market there. But one of the focus areas for Groq, especially as you're thinking of different use cases and how you can integrate our inference capacity into whatever systems you're building, really we focus on providing the best end-to-end response time per cost ratio. And this is an example of Llama 4 on Groq. And just kind of note, like for a lot of the open source models, like we were a day zero launch partner with Meta for the open source models, as well as a day zero partner of OpenAI for their open source 120B and 20B models. But as you can see here, basically Groq provides the best end-to-end response time by cost ratio. And that really comes down to the methodologies of what we wanted to focus on and differentiate ourselves in the market. A lot of times you'll either have trade-offs that you have to decide on, similar to if you're out there to purchase a car, the fastest car is going to be super expensive, right? Or if you want the most reliable car, there's so many different trade-offs and features. And so what we ended up really focusing on is basically speed, cost, and energy efficiency, how to maximize the return of investment on all of those three areas, which we see as something super critical, especially when you take a research project or a pilot you're developing and want to switch it to an enterprise, highly scalable application against millions and millions of users. And so our quadrant or focus area there you can see as being performant and economical. And so I'm going to take a second to talk through the Groq Cloud, and in a bit, we'll kind of walk through some of the different features there. But if you go to groq.com and go to our console.groq.com, you can basically sign up and get onto our free tier, and that's how you can experiment and test a variety of different models and use cases. And one thing to note here is that we have one-to-one compatibility with OpenAI's API. So if you are using OpenAI as API and you want to flip it over to test out running faster on Groq, highly encourage you to experiment with that. So a couple of the features of Groq Cloud, so we can do everything from JSON mode to running fine-tuned models, speculative decoding, function calling, native support for MCP, wide variety of things where we'll talk about some of those things in a bit. But just kind of talk a little bit about the public sector market that Tim and I are in and some of the things that we see. Basically, a lot of the individuals in the public sector that we talk to are super excited about integrating generative AI to solve problems and to develop systems that are more efficient and more effective for their key stakeholders. And so on the screen here is just a sampling of some of the different mission functions or enterprise functions that we see and talk to clients every single day on. But very interested in collaborating with people who are building out end applications or AI augmented decision support systems, or even experimentation on how generative AI can solve problems. And I know Tim is probably going to talk at the end of how we can collaborate on use cases and things of that nature. But we hear a lot of demand around being able to solve these problems. So super excited to see the end applications that our developers end up implementing within our Groq Cloud capabilities. And so just to kind of sum up some of the problems we solve. So at a core, the technology stack that we offer is really around how to drive really fast, high capacity, low cost, energy efficient AI inference across the board. On the public sector, we do offer on-prem hardware as well as providing access on the commercial side to the Groq Cloud stack, which makes it easier to sign up and experiment leveraging our hardware technology without having to have a place to host the physical infrastructure. And then basically one thing to note is just our supply chain differentiation of being able to have a very robust, easy to ramp supply chain that's de-risked by having a North American supply chain that can easily ramp up and accelerate to meet any type of compute demands. And so with that, I'll go ahead and switch over to a couple different demos that I wanted to walk through. So the first one here, if you go to chat.groq.com, this is really the easiest way to start playing around and just see how fast Groq can go. And here, I'm just going to go ahead and run through a quick example here. And this is using one of the open source models from OpenAI, a reasoning model. But basically, if I scroll up here to the top, you can see our tokens per second. And this is where you can look at things like your input versus output speeds and things of that nature. So in the top right-hand side, this is where if there's a particular model that you're currently using with another provider, you can just go down here and pick a particular model that you're interested in and run a little speed test on Groq to see how much faster we are. For your particular use case, you can then explore signing up for the Groq console and running those experiments directly with our API, which we'll talk about in a second here. So a couple different examples I wanted to showcase. We have what we call Groq Labs, which are basically starter kits to allow you to get started implementing and designing systems that integrate with generative AI models. This one, Groq Lab, is an example of a coding agent to go ahead and develop code for a particular use case. In this case, I'm developing a little calculator. So you see there within like 1 second, I was able to generate a working little calculator app So a lot of these Groq labs we provide is open source starter kits for people to be able to follow tutorials and go ahead and play around. Another example I wanted to showcase here is a computer vision example using Maverick 4 vision. And basically in this one, what I'm doing is I'm connecting to Esri satellite imagery and taking all of those satellite imagery tiles. And then as I move the map, I'm using our fast AI inference to be able to analyze all of those different chips and then see what the model can actually pick up and discern from that area. And so I come from a background of computer vision, and it's interesting to see the amount of use cases popping up today where people are able to apply these large language models to computer vision applications to do analysis of satellite imagery or other types of image analysis. And so if you log into the Groq console, wanted to just take a quick second to walk through some of the key features here. Basically, when you sign up, you'll be able to get your API keys up here in the top right. And on the left is basically the menu for all the different components of the Groq cloud that you can go through. If you have a text generation use case and want to see how to go ahead and set up a basic chat completion. We have the code snippets there that you can just copy and paste. If you're developing something like a speech to text or a text to speech or implementing image and vision analysis, similar to that previous demo we just looked at with satellite imagery, this you can basically go ahead and grab those code snippets to get started. Or if you're developing something with a reasoning agent or structured outputs, things of that nature. And we have a lot of built-in tools, so things like web search, being able to search the web as part of the backend of those API calls, or if you want to do browser automation or code execution or connect to Wolfram Alpha, things of that nature, totally available within our API stack. We also have the Groq compound, which we won't go into really that much detail today, but highly recommend you guys check it out. Basically, we recently outperformed OpenAI's 4.0 API web search with our compound AI compound agent. So highly recommend you guys experiment and test out with that. Another thing I wanted to point out is we do have native remote MCP support. So if you guys are developing MCP servers or implementing that within whatever stack you guys are building, highly recommend you guys check out our remote MCP support. A good place to start is the Groq API cookbook. And so we have a getting started guide with tutorials on how to set up, how to do things like your tool calling or implement your model context protocol, or if you have, let's say, retrieval augmented generation system you're building and want to implement Groq within that. This is a really good place to get started to implement whatever you're curious about building, but want to leverage Groq on. Another place that I wanted to just point out on GitHub here is our build with Groq repo. And so our software developers build a lot of open source repos for a wide variety of use cases and make them publicly available. So if you have, let's say, a particular thing like you want to develop a voice agent, we have basically custom templates, code samples already pre-built that are provided open source that you can just leverage, experiment with, and then create something off of those systems. So just to highlight a few, one of the ones that is rather interesting is our Groq code CLI. And so this basically allows you to do code generation with our open source CLI, where you can plug into a Groq model and see the efficiency and speed that we provide for coding tasks. So this is one I would highly recommend checking out. We also have a couple on voice agents. And so if you go to these repos, you can actually get a video of how it works with an overview, the architecture, to allow you to get started and then customize it for your particular scenario. And so I guess with that, I'll go ahead and stop and turn it over to Tim.
Thanks, Tim. That was great. I think Tim, you really highlighted some of the big ideas behind Groq, which are you can build really quickly with Groq. You can start very quickly with Groq. We work with a lot of startups and a lot of early stage companies that are really developing kind of their AI framework and approach. So there's a lot of pre-built templates and tools you can use in Groq to get you started. Highly recommend anyone just sort of play around with that. That's a real fast, efficient way to get started with Groq. And anyone can sort of sign up for a free version, look at some of the templates, look at some of the tooling to get started. So I think that's a great starting point. In terms of the work that Tim and I focus on, we're a public sector team. So we work a lot with U.S. Department of Defense, the energy labs, the DOE labs. So if there's anyone out there that has an interest in sort of either of those use case sets, for sure get in touch with us. I'll mention that we're going to be in a few weeks at SC25, the supercomputing conference in St. Louis. So if there's anyone interested in a meetup there, of course, we would be happy to meet and learn about your use case. What I would say, Tim covered a lot. You can look at the materials. If you have interest in engaging, I think everyone out there probably knows how the NAIRR process works to make a request. We certainly look at all of those. And Cassian, my Zoom is glitching, so I can't see any questions. I don't know if there's any questions in the queue that we need to cover. Or TK, I don't know if you see anything or not.
Yeah, we've got a couple. We've got two so far.
Okay.
So we've got.
If you could verbalize them, because
Yes, yeah,
I'm sorry.
absolutely.
Yeah, thank you.
So first question is, can you help me understand the security of running a model on Groq Cloud for use with non-public data?
Yeah, so Tim, do you want me to take this one?
Yeah, that would be great.
Yeah, so I highly recommend that you go to trust.groq.com, and basically that shows all our security compliance at Groq. One of the things to note is that we are SOC 2 Type 2 compliant, GDPR, HIPAA compliant, things of that nature. And so highly recommend you go to trust.groq.com. We don't store data within our inference. So a lot of the security requirements around like storing data are going to be at your application layer. So if you are developing a system and you have databases and storing that information versus the inference. On the public sector side, Tim and I see a lot clients that want the hardware deployed on site for very sensitive workloads. So if you're looking at things like defense and intelligence scenarios, or even sometimes in the commercial sector around really sensitive data, clients will actually opt to deploy on-prem, where they take our hardware and our stack and then run it in what we call an air-gapped environment. So there's a lot of different options there, but highly recommend that website to check out all the documentation.
Awesome. Thank you so much. We have another question as well. We have, do you currently have any HECVAT security assessments available?
So I don't know on that one on the top of my head, but yeah, just to recommend that website as well. It's trust.groq.com, just to see all the security assessments available. But happy to take that one as a follow-up.
Mm-hmm.
Sounds good. This was from an anonymous person, but it's the Higher Education Community Vendor Assessment Toolkit, HECVAT.
Okay.
Fantastic.
We'll take a look at that one, Cassian. Thanks.
Sounds good. Okay. If anyone has any other questions, again, please feel free to post them into that Q&A tool. This webinar will be, this has been recorded, and so this presentation will also be placed on the NAIRR Pilot YouTube channel for future individuals to come and check out. Let me go ahead and get this back up. Tim and Tim, thank you both so much for coming out today, for giving this
Of course.
presentation. Really, really appreciate it. It's a very unique tool. I'm very excited to explore it on the personal end as well. Um, and for everyone who, oh, I have another question from the Q&A too. One question for academia and educational research purposes, can you suggest a use case for inferencing real-time IoT data?
That might be one we have to take a look at, provide a response on. TK, I don't know if you have anything off the top of your head. That's probably a research one.
Yeah, I guess one thing I would recommend is if you want to experiment playing around with different data sets on Groq, I would take a look at our RAG implementations in the toolkits. Then you can leverage whatever open source data is on the internet or your own custom data and set up those scenarios and run it against a RAG implementation, leveraging our API.
Awesome. Thank you, guys. More questions as well. Is this the first version of the Groq processor? Is there a future roadmap?
We are on V1 of the Groq chips. V2 are going to be shipping shortly. We sort of do have a progressive roadmap that goes out 2 or 3 years. With the idea of being just continue to get higher performance with less energy, right? That's one of the main sort of ideas or thesis behind Groq. To sort of democratize AI inference, you need to just try to squeeze as much efficiency out of the platform as possible. Yeah, so more to come with future versions of the chipset. Mm-hmm.
Fantastic. And then another question. Do you plan on making the LPU hardware commercially available?
Commercially available in the sense of selling the hardware. I mean, I'm not quite sure I understand the question. We do sell it, as Tim TK pointed out, as a hardware platform. So it is commercially available. So it's available as a service, right? Groq Cloud. But we're seeing on the public sector side an interest in purchasing it as hardware, commercially available hardware that you then deploy at your location, at your data center. Mm-hmm.
Cool. Fantastic. Okay, I think that may be it for questions. But we are pretty early in regards to that. So if anyone has any other questions, please feel free to put them in the Q&A tool in the chat. Likewise, in the actual chat, you can find a post-webinar survey. If you've enjoyed it, if you have feedback, if you'd like to see something new, survey will take about 2 minutes and will allow us for the NAIRR pilot to produce more webinars like this. Again, Tim and Tim, thank you both so much for coming out today.
Thank you.
And what we have, okay, a clarification on the commercial hardware. Do you have any plans now or in the future for selling the actual LPU hardware by itself?
Yeah, so
go ahead, TK. No, go ahead.
Okay. Yeah, so there's a couple different ways to consume or inference against our hardware. The first one, which is the one a lot of people default to in the commercial sector, is part of the Groq Cloud. And so you can sign up for part of our multi-tenant for any of the models we have hosted on our hardware, and you can inference against that. The second one is basically where you can get a dedicated instance. And so this is a scenario where we manage the hardware at our own data centers, but you basically are renting, for all practical intents and purposes, the hardware to have your own dedicated hardware at our site that you can provide any custom model, let's say, that you want to run on that hardware. And the third option is what Tim and I were mentioning as something we see more prevalent in the public sector, where somebody wants the actual physical hardware and they have the space to be able to deploy and leverage that hardware and connect it to whatever network that they have. So we basically have the multi-tenant, pay-as-you-go option, part of the Groq Cloud. We have a dedicated instance where somebody can kind of rent a dedicated environment of our hardware in our space, run whatever models they want. And then that third option is basically someone can just buy the LPU data racks just individually. And then we, as part of that onboarding process, help them with the installation, the connectivity, and deployment in their data center, deployed into their network. And so that last option is something obviously that's a little bit more capital intensive than just signing up to play with, Groq Cloud for the free tier, of course. But especially if you have really sensitive data or a larger AI inference workload and you need that on-prem environment, yeah, we provide that capacity on both the commercial and federal sector.
Fantastic. Okay. And we don't have any more questions, I don't believe. So with that, thank you for presenting. For all of our attendees, thank you so much for attending. We aim to have a webinar, something like this, every week, not week, goodness, every month, once or twice a month. So please keep an eye out for your emails and keep an eye out on our newsletters for the next webinar up and coming. And with that, I will go ahead and give everyone a couple minutes back to their day as well. Thank you again and have a good one, everyone.